find the integral of tangent squared 5x dx. So we have got tangent squared 5x dx. Of course, we can change the tangent squared in terms of secant square, right? So we could use the formula, okay, tangent squared theta plus 1 is equal to secant squared theta. And of course, if you make tangent squared the subject, so you're going to end up throwing the plus 1 over to the right side, which would become minus 1 plus secant squared 5x. Negative 1 is easy to integrate. So negative 1, if you integrate with respect to x, is simply going to become negative 1 dx, which will be negative x. And we have got secant squared 5x. So if I can introduce a 1/5 outside and I can introduce a 5 inside, so it would be easier to integrate. So negative 1, if I integrate with respect to x, it is going to become negative x plus, so I'm introducing a 1/5 here because 5x when you differentiate, it's going to give you a 5. So I'm going to write inside the integral sign 5 times secant squared 5x, and the 1/5 is outside. Let's copy the 1/5. So the integral of 5 secant squared 5x is of course going to be tangent of fx. So tangent of 5x plus the constant of integration c, and of course we can rewrite it as minus x plus tangent 5x over 5 plus c. So that's how we integrate tangent squared 5x dx. Let's look at part B. Okay, so it says integrate sine 2x sine 3x, okay, from 0 to b as the limits, okay, with respect to x. So we are going to split this up, okay, using factor formula. So factor formula, we know that sine a sine b should be equal to negative of cos a plus b minus cos a minus b over 2. So we can just substitute the a with 3x and b with 2x. So if I put in 3x here and 2x here, it will exactly begin to look like this. So sine 3x sine 2x, okay, is equals to, so I'm just going to put in all the values over here as well. So negative cosine a plus b, so which is 3x plus 2x, which in the next step is going to become 5x, a minus b, so which is 3x plus 2x, okay, sorry, minus 2x, which is going to become x over 2. So now this is equals to cosine of 3x plus 2x is of course 5x, 3x minus 2x is x, so over 2. And then if you split this up, or we can just, you know, throw in the minus sign inside. Minus minus is going to become plus cos x, so that's why I've written the cosine x in the front, and minus times plus cos 5x become minus cos 5x. So it's cos x minus cos 5x over 2. So we could replace this, okay, with in terms of this. So therefore sine 3x sine 2x dx, okay, could be replaced with this. So integral of cosine x minus cosine 5x over 2. Now this 2 is basically a constant, so we can pull it outside the integration symbol in the next step. So this is going to become half, okay, only the numerator exists, right? So cosine x minus cosine 5x, and of course you can see that this is very easy to integrate. So we have got the half outside. Cosine x, if we integrate, it's going to become, okay, so I'm splitting it up first, okay, because of the cos 5x, so I want to put a 1/5 and I have 5 inside. So I put it as minus 1/5 and 5 cos 5x dx. So I have split this up, that's all. So if you can do it straight, so you go ahead and do it. So half, okay, cosine x, when we integrate, it's going to become sine x, right? So and 1/5, okay, 5 cos 5x, of course if we integrate, it's going to become 1/5 of sine 5x, but I have jumped a few steps because the upper limit is a b. So if you substitute all the x's with b, so you're going to end up getting sine b minus 1/5 of sine b. So I have jumped a few steps, okay, in because of the restriction of the space. So then you can subtract away, okay, of course sine 0 and sine 0 would have definitely given you 0, so that is why the rest of the terms I have not written, so it's all become 0. So what we have, so we have a sine b, okay, minus 1/5 sine phi b. Of course, I can throw in my half. So it's going to become 5 sine b minus sine 5b over 10 if you were to multiply it with a half and simplify. So that is the answer for integral of sine 2x sine 3x dx. Part C says find from a to b 1 over x, okay, times ln x dx, and we are told that a as well as b are both greater than 1. So let's look at how to do this. We have got a 1 over x, which is the derivative of ln x, right? So we could just write it as 1 over x as the numerator and just keep the ln x in the denominator. So in that way it becomes, this is like a function of x, this become f prime x, which is the derivative of the function, derivative of the denominator. So we could apply a logarithmic integration. So we know that if we integrate f prime x over fx, okay, it's going to become ln of the function x plus c. So I'm going to use this, okay, in order to simplify this, so or integrate this. So it's a ln of whatever that's on the denominator, which is ln x, okay. Then the limits are a to b. So I have already integrated. Now all that is left of us to do is to substitute the limits. So ln of ln b, okay, that is when you substitute x with a b, and subtract away ln of ln a, okay, when we substitute x with a a. So we end up getting this. But since we are told a as well as b are both greater than 1, right? So ln b, of course, is going to be ln of a number that's greater than 1. Okay, of course, between 0 to 1, the ln will be negative. But since this is greater than 1, ln b is naturally is going to become a positive number. Since it is going to be a positive number, we need not put the modulus or absolute value symbols. So we could simply remove them. So same thing for this ln a as well, because it's also greater than 1. So therefore ln a is definitely a positive number. So we're going to have ln of a positive number minus a ln of another positive number. We could use the rule of indices, okay, since both of them are positive. So we could just drop the modulus sign, and then this is like ln a minus ln b. So which is going to become, if you combine it, it's going to be ln b over ln a, okay, ln of ln b over ln a. So that will be the integration or integral of, okay, 1 over x ln x taken from a to b, definite integral. Let's look at part D. Use the substitution u is equals to 1 plus e to the power of 2x to find this, okay. This question is easy because they have the question examiner has already given you what is the substitution you need to do. So let u be 1 plus e to the power of 2x as given. So from this, okay, we can make e to the power of 2x the subject, because we need to substitute that for the numerator as well as for this part. So e to the power of 2x is simply going to become u minus 1, right, because if you throw the plus 1 over. So what is the value of du dx, because we need to get rid of the dx, right? So u, if I differentiate with respect to x, I'm going to get du dx. Of course, 1 if you differentiate is a 0. E to the power of 2x if you differentiate, it's going to become 2e to the power of 2x. We would differentiate the 2 and write it in front. So 2e to the power of 2x. Okay, our objective is to make dx the subject so as to replace it for the substitution. So what will be dx? If I bring the dx up and I bring the 2e to the power of 2x down, so it's going to become du over 2e to the power of 2x. But what is e to the power of 2x? Okay, if we want to express it in terms of u. So e to the power of 2x is simply u minus 1, right? So this part I could replace it with u minus 1. So therefore my dx is equals to du over twice of u minus 1. Okay, this is one of the way to do it. The other way is, of course, you could take this step and you can differentiate them implicitly, right? Or differentiate with respect to x. Okay, so you can find dx du, and you should be able to come to this also. Okay, so but I have chosen this route. So now it's time for us to just substitute all the values inside. So we are told to integrate e to the power of 2x over 1 plus e to the power of 2x cube dx. So what we're going to replace the e to the power of 2x with this, right? So u minus 1. So your numerator is going to be u minus 1 over 1 plus e to the power of 2x. E to the power of 2x, I'm going to replace it with u minus 1, right? So 1 plus, okay, e to the power of 2x is u minus 1, and then we have got a cube. And then in place of dx, I'm going to replace with this, because this is what dx is equals to. So dx would be equals to du over 2 times u minus 1. So let us simplify this expression before we move on. Here we have got a plus 1 and a minus 1, which could get cancelled. And here in the denominator, I've got a u minus 1, and on the numerator, we've also got a u minus 1, which we can cancel as well. So let's cancel the u minus 1 with the u minus 1, and let's cancel the plus 1 with the negative 1. So what do we have here? Okay, u to the power of 3, u cube, and we have got a 2 in the denominator as well. Numerator is just a 1. So it's going to simplify into 1 over 2u to the power of 3, 2u cube, and then du. So we need to integrate with respect to u. So now you can see this is a very simple integration. Okay, so you can just take 1 over 2 outside. So what you're going to have inside the bracket, inside the integration, is u to the power of negative 3 with respect to u. So what would this be? U to the power of minus 3 plus 1 is going to become u to the power of minus 2 over minus 2 plus the constant of integration c. And of course we can simplify this and write it as minus 1 over 4u squared plus c, which is, you can put back what the u was, because u we have taken it as 1 plus e to the power of 2x square plus c. So that's how, okay, using substitution we can solve this part of the question for 3 marks.